Okay, on 61, on section 1.4, we can figure out a lot of things given the information we have. First of all, they tell us our x-intercepts are at 2 and at 3. Hopefully I wrote that down wrong. Right. Nope, I'm glad I checked. They're at 2 and negative 3. So they're at 2 and negative 3. Ignore that dot, red dot on 3. I'm just going to put like an X through it. Okay, now, if you look, and I'll show you where this information is in your book, on page 45, to do number A, when you see f of negative x, that's a reflection in the y-axis. So I'm just going to put reflect y-axis. Since it's a reflection in the y-axis, I'm going to just, like this 2, it's 2 away from the y-axis, so the new function would have negative 2 to match up with that 2. And our other x-intercept was negative 3. So if I reflect it in the y-axis, I would go 1, 2, 3. And so 1, 2, oh, that one that I put an x on would end up being my new y-intercept for this A part. So my y-intercepts on A would be negative 2 and positive 3. Okay? Now negative f of x is a reflection in the x-axis. So let me use a different color just so I know this page is going to get cluttered, but we're adding one thing at a time. Reflection in the x-axis. Well, if you're going to reflect around the x-axis, but you got points sitting on the x-axis, then the original points are the same. So they're going to be 2 and negative 3, the original points. Now 2 times f of x, if the y value's there, if you think of f of x as being your y value, all you're doing is doubling your y value. Well, if my y value was 0, remember the original was 2 and negative 3. Let's look at x equal 2. My y is 0. So if I double 0, I still get 0. So my original 2 is still an x-intercept. And likewise, if I had a y value of 0 at negative 3, remember that's the point, negative 3, 0. If I multiply the y value by 0, 2 times 0 is 0, it means that's still the x-intercept because the y value is still 0. So I'm going to have my original also on C. Okay, D says take your original y values and scoot them down 1. So if the red values are my original values, they're each going to get scooted down 1. Now the problem is that's all I really know about this function. I don't know anything else about it, so if I scoot them down and they want to know where my new y-intercepts are, I really don't know what other point could be a y-intercept there. There's just not enough information on this one because it's a vertical shift. So I can't determine that one. But on E, if you think about it, when they write this f of x minus 2, this is kind of like when you were writing a function, if there's something in the parentheses with the x, that's your horizontal shift. So this is telling me there's a horizontal shift going on, and because it says x minus 2, remember with the x, there's always a subtraction sign, so it might look like it would be left 2, but it's really right 2. So what I'm going to do to figure this answer out is move all my, I'm going to actually switch colors. I meant to do that and I didn't. I'll use a light purple here. My original values are still on those red ones that are on the graph. If I shift everything right 2, this one is at 2, it goes to 3, 4. So now I got a y-intercept of 4. And if my original one was at negative 3 and I shift it right 2, it shifts over to, negative 1. So this I can do because it's a left or right shift, so my zeros are just being, my x-intercepts are just being shifted left or right, and I know by how much, so I can determine that. But when they move them up and down, and they just give us this notation, we don't know enough.